Hey, it's Dr. J. I'm here at the College of the Desert Learning Glass studio to go over one example that I've received about 10 emails this week about this particular problem. So instead of replying to 10 or possibly more individuals, I thought I'd just make one video and show everybody how to do this problem one more time. So this is a business problem, revenue, cost, profit. The first thing we're going to do is read the question. So we have a family farm, grows almonds. To produce 190 pounds of almonds, the cost is $3,680, $3,680. If they increase the quantity to 340 pounds per growing season, notice the cost only goes up a few $100, $300. And you get quite a much larger harvest from a small increase in cost. So that tells us something about the rate of change of the per pound cost. They also sell these almonds for $12 a pound. We'll go ahead and wait on that. We'll come back to that later. We're not really going to sell the almonds until we grow them first. So the first thing we want to do is let X represent the number of pounds. My pen coming up? Maybe this one's better. Yeah, that one is better. So we'll let X represent the number of pounds, and we want to find a linear model, or I'll just call it a model. It's the only type of model we've done so far. C equals AX plus B. I have to get out of the way so you can read that. So that's our cost model. Notice it's the same as Y equals MX plus B. We've just dressed it up using some different variables. All right, so let's find the A. Let's find the slope. Now remember, X represents the number of pounds. So when we find our slope, our A, when we find our slope, we're going to make sure that we put the A values in the X values in the denominator. Okay. So our X values are the number of pounds. So let's call that X2, call that X1, and we'll subtract the number of pounds. 340 minus 190. That'll tell us the difference in those two harvests, the difference in the number of pounds. Okay. And then we need to associate the corresponding costs. Yeah, so this is cost 1. That's the cost for 190 pounds. And that's cost 2, the cost for 340 pounds. So we'll subtract, find the difference in cost as well, which we already noticed, or I already noticed that it's not very much. It's only $300 difference in price and cost per pound. And then the number of pounds is quite different. That looks like 150 pounds difference. So the difference in cost is $300. The increase in the quantity is 150 extra pounds. And so that's $2 per pound. Yeah, 300 divided by 150 is 2. So this is our rate at which we can produce the almonds for $2 a pound. All right. The next thing we need to do is find the fixed cost. So this is our rate per pound. Now we need to find the fixed cost, sometimes referred to as overhead. Right? It's the price of the labor and the rent. Yeah, you got to pay the rent, other things like that. Things that are fixed. Even if you have a terrible season, and the almonds don't grow, you still have to pay the rent. So that's the fixed cost. All right. So what we're going to do is take this model, right, and solve it for B. So notice B, if you solve for it, is just C minus AX. Yeah. B is equal to C, the cost, minus the AX, and I've rewritten it so that the B is on the left-hand side. And you can use either one of the costs, but make sure that you use the corresponding number of pounds. So if I do the cost of 3,680, 3680, right? I know that my A is $2 a pound. Now, if I choose 3680 as my cost, then I have to use the corresponding 190 pounds. It really doesn't matter which pair you pick, but if you pick, you must pick its associated number of pounds. So for example, you wouldn't want to pick 340 pounds, but then pick the wrong cost that doesn't associate with that. So they have to be corresponding to each other. All right. I'm running out of space. So I'm going to move over here. I really should have worn a darker shirt. So I've got 3680 minus 2 times 190. So that's 3680 minus 380, which is $3,300. So those are our fixed costs. And again, even if I don't grow any almonds, even if I don't sell any almonds, that's your overhead. That's just your price of doing business, the cost of doing business. Okay. All right, so now we've got our cost model. Is C equals $2 per pound plus the overhead of $3,300. Now, at the beginning of this problem, I said we would wait on the revenue because we're going to sell the almonds for $12 a pound. The reason why we wait on the revenue is because there's really not a lot of work that goes into finding the revenue. All right. To find the revenue, it's very simple. R, think about it, common sense, right? Revenue is just how much you're bringing in, right, after selling the almonds. X is the number of pounds, $12 per pound, so the revenue is 12X. There's not a lot of digging, there's not a lot of solving. You just think about, well, $12 per pound. If I sell 1 pound, it's 12 times 1. If I sell 2 pounds, it's 12 times 2. If I sell 100 pounds, it's 12 times 100. So the revenue is 12X. And there you go. That's all the work for this problem. We're going to answer a couple questions related to this problem. One of the questions that's very important is not just how much you're spending and how much you're bringing in, but how much you're actually making, right? Profit. Yeah. The profit. The profit is the revenue minus the cost. So we have our revenue function, a revenue equation, which is 12x, minus our cost equation, 2x plus 3,300. Notice I'm using parentheses. It's very important. If you don't use parentheses, you might forget to distribute this negative sign and it could cause an error. I'm trying to make it look a little cleaner. There we go. So now we're going to distribute this negative. I'm going to write the word P as profit. It's the letter P for profit. So I have 12x minus 2x minus 3,300. So my profit equation is 10x minus 3,300. All right. It should be rather intuitive, right? You're selling them for 12, but it's costing you 2. So your profit is 10. Yeah. And then when you're talking about cost, the overhead is a positive number because it's cost, right? You pay the bills with real money. I guess you can pay it with debt. But when you think of it as profit, it becomes negative. Yeah, because you're immediately in debt. You immediately owe $3,300 right off the bat. Yeah. So what used to be a positive cost now becomes a negative profit, which really means if you don't sell any almonds, you owe $3,300 because you didn't sell any almonds. Okay. So that's it for the business profit, revenue, cost models. There are some associated questions that we might ask about this. I might ask, how much profit do you make if you sell 1,000 pounds? I'm not going to do it on this board, but I'll leave that as a DIY. If you sold 1,000 pounds, do it yourself, just plug in 1,000, and this model will predict the profit for selling 1,000 pounds. The one question I am going to ask is the one that's on the quiz or the homework or possibly the next test, is the break-even point. Yeah, how many do you have to sell? How many pounds do you have to sell to make nothing, just to break even. All right. So remember, breaking even means that the profit is equal to 0. So if the profit is equal to 0, that means that the revenue and the cost are equal to each other. Yeah, so if revenue is equal to cost, these things are equal to each other, then that means your profit is 0. You brought in some money, you spent some money, those things are equal to each other, and so your overall profit is 0. All right, so we take this model and we set it equal to 0. And we solve for x, and that'll tell us how many pounds we need to sell in order to break even. A lot of this can be done with mental math, right? I mean, you could probably guess right now 330. Yeah, not a bad guess. Look, 330 times 10 would give you exactly 3,300. But estimate in your head, but calculate with your hand, okay? So you get 3,300, 3,300. So I get 10x, these are canceled out, equals 3,300. I'm running out of space, aren't I? You can't see that because it's below the camera view, so I'm going to rewrite that. 10x is equal to 3,300. Divide both sides by 10. And just as I predicted, 330 pounds. So that's our break-even value. Okay, this is really just an experiment. I've spent some time getting this all set up, and I'm still working out some of the bugs, but pretty short one-question video. Hopefully it was helpful to you. So until we meet again, this is Dr. Jordan. I'll see you on the internet.